Hello everyone, welcome to lesson 12.4. It's a little darker in here again. That's because we're going to do some definitions and you really need to be able to see the words up on the board and the charts. So don't mind the darkness. Let's pay attention here. 12.4, you're going to be able to describe a data distribution by its center and its spread. Basically, we're going to look at some data and we are going to see how it's distributed. We're going to talk about distribution, okay? And we're going to see what the best measure of center is going to be and the best measure of spread, which the book uses for the first time here, which basically means best measure of variation. So for measure of center with this data, are we going to use the mean or the median? With the measure of spread or variation, are we going to use interquartile range, or are we going to use absolute deviation? That's the word. All right, and we're going to describe its overall shape. So this is something kind of new here. Let's get going. All right, let's talk about this vocabulary. Distribution. How data is arranged, okay? So is the data kind of spread out? Is it close together? Are there gaps? Let's talk about some of the words we might use today and tomorrow. Clustered. The data is grouped close together. So if you're looking at like a line plot, you have a group of data that's right together. All right. If it's gapped, it might have some clusters and then an open gap, and then some clusters and an open gap. All right. Gap means there are no value. It's zero value. Symmetrical. You might not run it into data that's very symmetrical in the real world, but you might run into some in your book. So symmetrical means the left side looks like the right side, just like a human being is symmetrical. All right. This half of my body is the same as both halves are the same, basically. All right? I might have one arm or leg that's taller than the others. And last word, peak, the tallest, most frequent number used, which is the moon. But we're really going to talk about the clusters, the gaps, and the symmetry here. So we're going to refer back to this page when we need to. So here's our first example. Let's describe the shape of distribution here. Already I could see a gap at 15. I can see a big gap between 19, 20, 21. There is no data. All right, because there's a gap, I have some clusters. I have a clusters of data on this side to the right of my gap, and I have clusters to the left of my big gap. So if I'm describing this using our new vocabulary, we have some clusters, we have a big gap. There is no symmetry here. If I want to talk about the peak of my data is with the temperature of 22 degrees Fahrenheit. That's what occurred the most during this time period of temperature. All right, so clusters, gap, clusters. There is no symmetry, not in this one. Let's look at the next one. Now this one, I don't really see any clusters or gaps. It's kind of hard to read on a box and whisker plot, but I could definitely see some symmetry here. All right, because here's the middle of my data. And from the middle to my quartile 1, I have 20 visitors. From the middle to quartile 3, I have 20 visitors. So from there to there is 20, from there to there is 20. From my quartile 1 to my extreme is also 20. And from quartile 3 to my upper extreme is also 20. So from the median to my lower extreme would be 40, and from the median to my upper extreme would also be 40. So you could see there's a line of symmetry right at the median. All right, this side is equal to this side. I can't see if there's any clusters because this only shows 5 points of data. All right, I don't know if there's any gaps either because of this type of graph. All right, so here's the second half of the lesson. If we go back to the beginning, we said part of our objective is to describe the distribution by its measure of center and its measure of spread. Okay, so this is in your book. I'm not sure what page, but it's this very similar chart. It says using the correct measure of center and spread, which is measure of variation. If the data is ask yourself this question. Is the data distribution symmetric? So, is it more like example 2 than example 1? If it is symmetric, if there's symmetry, you would use the mean for the measure of center, and you'd use absolute deviation for the measure of spread, meaning variation. All right, so if you would use mean and absolute deviation for something that looks like this. Mean and absolute deviation would be your measures of center and your measures of spread. Now, if it is not symmetric and there's gaps and there are clusters with gaps in between that doesn't look equal on both sides, you would use the median to describe measure of center, and you would use the IQR to describe measure of spread. All right, so let's go back to that other example. Talk about this example right here. There's clusters here. So because they're kind of far off and there's no real uniform shape to it, you would want to use the median, the middle number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7, 8. Between 7 and 8, your median would be 22. Now you could find your mean as well, but the median would be your best measure of center here. Best measure of center here would be your mean because it's evenly distributed. Okay, so this chart will be helpful. It's in your book to decide if you need to use the mean or the median for center and the absolute deviation or the IQR to describe measure of spread. So let's try one together. Number of states visited. All right, what measure of center would I use? Let's say this is the states I visited or people have visited. Some people visit 10 states, 3 visited 10, 5 visit 11. One person actually visited 19 states. So, but that's neither here nor there. Let's talk about measure of, well, let's first look back to here. Is the data distribution symmetric? And we're going to say no. It's not symmetric because it's not equal on both sides. All right? It's not symmetric. There's a big gap and there's a cluster and they have probably an outlier out that way, possibly. All right, so since it's not symmetric, I'm going to use the median to describe my measure of center and the IQR, our interquartile range, to find measure of spread for this one. All right? If I could find the mean, I could find absolute deviation, but they're not going to be your best measures for center and spread. Let's look at this one. Now, this is a great example of forming symmetry. All right, if this is my middle point here, I have 4 and then 4, 3 and then 3, 2, 2, 1, 1. This is perfect symmetry. On both sides, it's exactly the same. All right, and this is ages of tennis players in years. Some are 25 years old, and there's one that's 33 years old. All right, now because this is very symmetric, looking back on this chart, I'm going to want to use the mean for measure of center. All right, so I would add up all these numbers and divide by how many they are, and that would be my best measure of center. How about measure of spread or measure of variation? I would have to use absolute deviations, all right? So how far does each number deviate from the mean that I found? And that's what I would use on this one. Best measure of center is the mean. Best measure of spread is absolute deviation. And absolute deviation, if I go back to this chart, absolute deviation and mean both involve the mean. IQR and median both involve the median, okay? That's a good little point to recognize right there. So here's your job tonight. You have to, looking at this number of hours spent on the internet, one person only spent 1 hour, 2 people spent 2 hours, you have to describe the shape of distribution here. So is it symmetric? Is there clusters and gaps? Describe it for me. Maybe even tell me where the peak is. Number 2, choose the appropriate measure of center and variation. So with this, for measure of center, would you use the mean or the median? And then for the measure of spread, would you use absolute deviation or IQR for this chart right here, okay? So you have 2 questions. They should be pretty quick and easy. All right, you're just looking at these graphs. You don't have to write too much. You don't have to copy the graph down. Good luck, and I'll see you tomorrow.